I want us to look at a transformer. Our lesson today focuses on a transformer. What is a transformer? A transformer is an electrical device which transfers electrical energy from one coil to another coil. So the source of power is connected to one coil which is called the primary coil. And then that electrical power which is in the primary coil, and it must be an AC, an alternating current, is transferred to the second coil which is called a secondary coil by mutual induction. Mutual induction. So we have a coil where we have the power which is an AC, it is fed in the primary coil, and then we have the secondary coil where we shall induce an EMF in the secondary coil by induction. A transformer is as shown below. A transformer is as shown below. This is an AC power source. So this circuit, the first coil, this one, we call it primary coil. That is where the AC power source is fed into. And then this coil is wound on a soft iron core. And then the secondary coil is on the other side. Secondary coil is wound on the same soft iron core. Output. So we are saying a transformer consists of two coils. The first coil is the primary coil where we have our source of alternating current being fed into. And then this electrical energy in the primary coil is transferred to the secondary coil where we have our output by mutual induction. It is as simple as that. That is what we call a transformer. We have two types of transformers. The first transformer is called step-up transformer. We have a step-up transformer. So in a step-up transformer, the amount of voltage in the primary coil is lower than the amount of voltage, this one, the primary coil is lower than the amount of voltage in the secondary coil. It is this voltage which is stepped up. It is stepped up. And the current in the step-up transformer, in the primary coil, we have current which is more than the current in the secondary coil. How is it stepped up? In a step-up transformer, the number of turns in the primary coil are fewer than the number of turns in the secondary coil, as shown below. So in a step-up transformer, it looks like this. This is our soft iron core. Then our AC source, power source. Then so this one is a step-up transformer. Why? We have fewer number of turns in the primary coil than the number of turns in the secondary coil. So we can clearly say that the number of turns in the primary coil is less than the number of turns in the secondary coil. This is what we call a transformer, and the symbol, the electrical symbol of a transformer, this one, step-up transformer, is this one. First, this is our source, AC source, and then we have our output. This is the electrical symbol of a step-up transformer. The voltage is stepped up and the current is stepped down. Why do we step up voltage or the EMF that is induced? It is stepped up so that it can travel over a long distance. In fact, such transformers are usually found next to a power plant. After the EMF has been produced in a power plant, it is stepped up so that it can be transmitted over a very long distance. You know, when the current is moving over a very long distance, we would have a lot of power being lost. Now, to minimize the power losses, we step it up so that the current in the secondary coil is very low. And therefore, the amount of EMF, the amount of power that's going to be lost is less. Very good. So in this case, in a step-up transformer, the NP/NS ratio, we call them the turn ratio, the primary turn, the number of turns in the primary coil over the number of turns in the secondary coil is usually less than, no, not greater, less than 1. Is that okay? I hope we are together. The next type of a transformer is the other one. We have another type of a transformer class. The next type of a transformer is a step-down transformer. We have a step-down transformer. After the very high voltage has been transmitted over a very long distance, for people to use it, it must be stepped down to the required voltage. Let's say maybe 240 volts or 220 volts, so that it can be used by the appliances that people have at their homes. So what do? We must step that voltage down using a step-down transformer. So what is a step-down transformer? This one consists of the same number of coils. We have the primary coil and the secondary coil. The difference now between this one and the step-up transformer is that this one has very many number of turns, more number of turns in the primary coil than number of turns in the secondary coil, as shown below. Good. This is our soft iron core. And then the primary number of turns in the primary coil is our source, AC power source. And then this is our output. You can clearly see the number of turns in our primary coil are more than the number of turns in the secondary coil. So that means that the ratio, the turn ratio, NP over NS is greater than 1. The turn ratio is greater than 1. It means that in this case, the voltage in the primary coil is greater than the voltage in secondary coil. That is it for the day.